awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun, kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula. Assalamualaikum and hi everyone, welcome back to my channel. Jika anda pertama kali hadir ke channel ini, selamat datang saya ucapkan. Tapi jika anda pernah hadir dan kembali semula, tahniah kerana rajin dan sudi kembali. Jadi dalam video kali ini kita akan sambung dengan subtopik 8.2 berkenaan dengan Equilibrium of Rigid Body. Tapi sebelum kita mula jawab beberapa soalan berkaitan dengan Equilibrium of Rigid Body, let's revise some equations that relate to chapter 8. Okay, so here is a table of equation for linear motion and rotational motion. So you can see here the comparison between equation of linear motion dan juga rotational motion. So based on this table, okay, kita boleh buat comparison. Alright, so in linear motion we have linear acceleration A, but in rotational motion we have angular acceleration. Sama juga macam V. In rotational motion we have omega, which is angular velocity. And bila kita turun bawah yang berwarna kuning ini, so in linear motion we use M as a mass of the object. But when we talk about rotational motion, we need to consider the moment of inertia for the body I. Okay, and P is the linear momentum, but in rotational motion we have L, which is angular momentum. P is equal to mv, L is equal to M tadi dah jadi I kan? So I omega. Alright. And how about equation of total force is equal to MA? So bila ada nilai total force ke atas objek itu boleh bergerak with an acceleration of A. Sama juga dalam rotational motion. Bila ada turning effect, kita panggil total torque. So bila ada total torque in that system, so kita boleh kira angular acceleration of the object. Maknanya bila objek itu berputar ataupun rotate, so kita boleh kira total torque of the system is equal to berapa. Jadi pada video kali ini kita akan fokus kepada equilibrium of rigid body. Jadi kalau kita sebut kepada equilibrium of rigid body, maknanya objek itu tidak bergerak. So kita kena consider dua perkara, iaitu translational equilibrium means that total force in X component is equal to 0 dan total force in Y component also equal to 0. Means that all external forces acting on a rigid body must be 0. And the vector sum of all external torques acting on a rigid body must be 0. Maknanya total torque also equal to 0. Bila total torque is equal to 0, maknanya objek itu berada dalam keadaan rotational equilibrium, tidak berputar. Okay, kalau total Fx dan total Fy is equal to 0, means that the object is not moving in X component dan objek itu juga tidak bergerak in Y component. Okay, so sekarang kita akan sambung dengan example number 1. Alright, now let's start with example number 1. So here we have three masses are attached to a uniform stick as shown in the figure. The mass of the meter stick is given 150 gram. So I will write the mass of the meter stick in kg should be equal to 0.15 kg. Okay, so make sure you change from gram to kilogram. So 0.15 kg. And the masses to the left of the fulcrum are M1 equal to 51 kg. So it should be equal to 0.05 kg. And M2 is 75 gram. Okay, so 75 gram should be 0.075 kg. Okay, so now find the mass M3. So we want to find mass 3 that balance the system when it is attached at the right end of the stick. and the normal reaction force at the fulcrum when the system is balanced. Okay, so means that we want to find what is the mass of M3, and then we want to find the normal force at the fulcrum when the system is balanced. Okay, jadi perkataan balance ini menunjukkan this system is in equilibrium. Means that total force in Y component is equal to 0. Okay, and then total torque is also equal to 0. Saya tengok dalam sistem ini tiada force in X direction ataupun in X component. So now let's try to draw all the forces on the stick. So the first force is W1, second is W2, and the third one is W3. Okay, dan kemudian kita akan ada normal force which is upward direction N. Dan jangan lupa for uniform rigid body, kita perlu letak another force which is the weight of the stick, which is located at the center of the stick. So saya letak tengah-tengah sini contohnya. Okay, so the length of the stick is given in the diagram. We have 30 cm, 40 cm and 30 cm. Okay, maknanya panjang bagi stick ini adalah 100 cm. Okay, so this is the pivot. Alright, so look at here. So I will highlight with the blue color, and this is the pivot point. Okay, pivot. Okay, so saya akan letak satu lagi, the weight of the stick, SWS. Okay, and then from the diagram, okay, you must know that the position of W1, jadi W1 terletak di mana? So jaraknya daripada pivot adalah, kita boleh nampak kan, which is 70 cm here. Okay, and the position of W2 pun sama, kita tak ada masalah kan, kita boleh tengok saja ini which is 40 cm, and then we have mass 3 which is 30 cm from the pivot. And how about the weight of the stick? Alright, so the position is kalau sini tadi 30 cm, di bahagian sini dia duduknya di tengah-tengah stick tadi, which is the length of the stick kita dah tahu. The length of the stick should be equal to 100 cm. So bila weight of the stick is located at the center of the stick, so means that jarak dia daripada pivot ini should be 20 cm. Okay, so 20 cm tukar kepada meter lah. Semua yang sentimeter jangan lupa tukarkan kepada meter. Boleh. So now let's write total Fy is equal to 0. So bila kita tulis total Fy is equal to 0, okay, since the system is in equilibrium, okay, so now let's write the equation. The direction of normal force is upward, so positive N plus negative W1 plus negative W2, since the direction is downward, plus negative Ws plus negative W3 is equal to 0. Sekarang kita nak kira mass 3. So look at this equation. Okay, kita nak cari mass 3 since we know that W3 is equal to M3G. So kita ada nilai ini dan ini, tapi kita tak ada juga nilai normal force. So we cannot solve this question by using equation total Fy equal to 0. So we proceed to another equation and let use total torque is equal to 0. Okay, so sistem ini berada dalam keadaan equilibrium. Dia tidak bergerak dan dia juga tidak rotate. Okay, so kita tulis total torque. So now look at the position of the pivot point. So this is the pivot point. So always remember, any force that exerted on the pivot, nilai torque dia akan jadi 0. Okay, so kalau kita tulis dekat sini, automatically saya tahu, saya tengok pivot dekat mana dan saya nampak ada normal force exerted on the pivot. So torque bahagi normal force is equal to 0. Okay, maknanya kita dah tahu kan, kalau kita meletakkan force pada pivot of the system, dia tidak akan memberi apa-apa turning effect kepada kayu tersebut. ataupun sistem tersebut. Okey, jadi sekarang kita tengok force yang lain. Kita ada W1, W2, Ws dan juga W3. Jadi untuk example yang pertama ini, saya akan tunjukkan satu-satu untuk tunjukkan dekat awak the value of the torque should be positive or negative value. So before we start, so let's write the equation first. So we have torque W1, so I will put torque 1 plus torque 2, sebab ini adalah total total torque kita tambahkan semua nanti. Torque 1 plus torque 2 plus torque due to the weight of the stick plus torque 3 is equal to 0. Okay, saya hanya tulis sahaja dahulu. Kita tak tahu torque 1, torque 2, torque 3 dan torque S ini positif ataupun negatif. So now, let's start with the first mass. So I will write here. Okay. So now mass 1. Okay, so let's start with mass 1. Alright. So this is the pivot point. Okay, kalau tak boleh imagine dia clockwise ataupun anti-clockwise, awak lukis macam ini. So this is the pivot point, pergi ke arah W1 and the direction of W1 should be downward direction. Okay, and the pivot point is here and I will write R1. So R1 is the distance from the pivot point, daripada pivot point ke tempat di mana force itu diletakkan, iaitu W1. So R1 tadi kita dah tengok it is 70 cm. Okay, look at here. So it is 70 cm from the pivot. So I should write here 0.7 meter. And W1, saya akan terus kira W1, which is mass 1, 0.05 kg times 9.81. Okay, so kita tulis dulu macam tu. And what is the direction of the torque? Okay, so it is anti-clockwise direction. So means that torque 1, the value should be positive value. Okay, so kalau kita nak kira dekat bawah ni, kita boleh terus tulis torque 1 is equal to positive R1 W1 sin 90 degree. Okay, so kalau kita nampak semua force exerted here is 90 degree. So sin 90 is equal to 1. Di sini saya akan terus saja ambil angle antara R1 dan juga W1. So let's substitute all the values. So we have 0.7, W1 we have 0.05 times 9.81. So torque 1 kita akan dapat positif 0.343 Newton meter. So ini baru kita cari torque 1. Okay, bagi sesiapa yang nak buat table, tak ada masalah, boleh teruskan. Tapi saya di sini tidak buat table lah. Saya hanya buat satu-satu untuk menunjukkan what is the direction of torque based on the force that exerted by the mass. Okay, so finish mass 1. So we proceed to the second part, which is mass 2. Okay, so let's try here. Okay, so now let's write mass 2. So mass 2, okay, so let's draw. This is the pivot point. So from the pivot point, so from pivot point to the point where we put a force W2, which is downward direction, and this is R2. Jaraknya daripada pivot ke W2 adalah 40 cm. Make sure you change to meter. And W2 is equal to, kira lah nanti, 0.075 times 9.81. Alright. So, the direction of the torque also anti-clockwise direction. Okay, so positive value. Saya tunjuk sebelum ni, daripada pivot, awak gerak ke sini, turun bawah. Lepas tu kalau nak patah balik ke pivot, jalan mana yang paling dekat? Iaitu ke sinilah, iaitu anti-clockwise direction. Okay, kalau kita imagine pun, logiknya kalau kita letak force in this direction, okay, stick itu akan rotate in anti-clockwise direction. So, the value of torque should be positive. Okay, so torque 2 is equal to positive R2 W2 sin 90 degree. So sin 90 degree is equal to 1. Okay, so let's substitute all the values. Okay, and then the answer for torque 2 should be positive. 0.294. Okay, awak cuba kira dan cuba semak kiraan saya. So now let's proceed to the third one, which is the value of torque due to the weight of the stick. Okay, weight of the stick, iaitu WS. Alright, so let's try to sketch. So this is the pivot, and then this is direction, and this is the direction of WS, the weight of the stick. Okay, and saya letak RS, iaitu distance daripada point P, iaitu pivot, ke WS tadi, pada pivot here, okay, to here should be 20 cm. Okay, and the mass of the stick is given 150 gram. So kita tukar kepada kg, and let's find the weight. 0.15 times 9.81, and it is 90 degree. Okay, so the direction also anti-clockwise direction. Okay, so the value of torque S should be positive. RS WS sine 90 degree. Okay, so let's substitute plus 0.2. Okay, WS is 0.15 times 9.81. Okay, kira, so positive 0.294 Newton meter. Okay, and then the last one. Okay, so I will write here. Okay, the value of torque due to mass 3. So let's draw here mass 3, and this is the pivot point. Okay, and then this is R3, which is 30 centimeter from the pivot to this point, and W3, which is equal to M3 times G. So M3 yang kita nak cari, ini yang kita nak cari, ini kita punya objektif. Okay, so now the direction of torque should be clockwise direction, so torque 3 should be negative value. Okay, so torque 3 is equal to positive, okay, R3 W3 sine 90 degree. So this is 90 degree, right? Okay, so let's substitute R3 0.3, W3 kita tak tahu W3 berapa, so M3 times 9.81. Sorry, torque 3 ni adalah negatif. Okay, jangan careless clockwise direction should be negative. Okay, so 0.3 times 9.81 saya selesaikan dulu. So negative 2.943 M3. So jawapan ni belum ada lagi. So this is in terms of M3. Okay, so since the system is balanced ataupun equilibrium, so let's write total torque is equal to 0. Okay, so kita dah kira semua tadi. Torque 1 plus torque 2. So jom kita tambah. Torque 1 is 0.343 plus torque 2 is 0.294 plus torque 3. Torque 3 kita tadi negatif. Okay, so tak muat dekat sini. Saya tarik sikit ya. Okay, negative 2.943 M3, okay, plus torque S, iaitu due to the weight of the stick, 0.294 equal to 0. Okay, so rearrange this equation. Finally, you can find what is the mass of mass 3. Okay, so kita akan dapat nilainya. Cuba awak kira, practice kira. So, you akan dapat, therefore, M3 is equal to 0.316 kg. So, this is the answer. Okay, dan sekarang soalan juga suruh kita kira the normal reaction force. The normal reaction force at the fulcrum. Okay, when the system is balanced. So, kita nak kira normal force. Okay, so I will use total force in Y component. Okay, so saya akan tulis dekat sini. Total force in Y component is equal to 0. Okay, sebab dia balance kan, dia tidak bergerak atas dan bawah. Dia tidak berpusing. So, bila dia tidak bergerak ke atas ataupun ke bawah, so total Fy is equal to 0. Okay, So kita dah tulis tadi, di awal tadi kita dah tulis equation total Fy is equal to 0. This one, N minus W1 minus W2, okay, minus W3 dan minus Ws equal to 0. Okay, so kita boleh tulis balik lah kalau kita nak tulis. Sekejap okay, segera semula. Okay, so total Fy, kalau nak tulis balik, kita tulis kat sini N minus W1 minus W2 minus W3 minus Ws is equal to 0. So now normal force is equal to weight 1 plus weight 2 plus weight 3 plus weight of the stick. And then normal force is equal to, kita kira lah. Semua ni akan darabkan dengan G kan. So saya akan factorizekan G. Saya tulis satu-satu lah untuk awak. So G, M1 plus M2 plus M3 plus mass of the stick. So M3 kita dah kira dah tadi nilai dia. So kita boleh masukkan nanti. Okay. So M1 is 0.05 kg. M2 0.075 kg plus M3, M3 kita dah dapat tadi kan, 0.316 plus the mass of the stick is 150 gram, tukarkan kepada kg. Boleh. Okay, and finally you akan dapat jawapan normal force is equal to 5.8 Newton. Okay, so finish example number 1.